So when talking about half-life, what we're going to be doing here is calculating the amount of a substance remaining after it's gone through X number of half-lives. But let's first talk about the concept of half-life. Half-life is a measurement of time. More specifically, it's a measurement of the time it takes for half of a substance to decay, and it's going to decay through nuclear reactions. So if we originally started off with, say, 20 grams of something, that was my original mass, after one half-life, which I'm just going to abbreviate 1HL, we would have half of it remaining, or 10 grams. After two half-lives, we would have half of the half, so half of 10, which is 5 grams, which is of the total 1/4. After three half-lives, we would have half of 5 grams left, which is 2.5 grams. Of the initial 20 grams, 2.5 is 1/8. And so on and so forth. 1/16th, 1/32nd, 1/64th, so on and so forth. And it would just keep going and going and going. And there's always a little bit left over. Well, what you can do for half-life problems is if you're given an original mass and you're calculating how much is left after, 4 half-lives or 10 half-lives, you just divide by 2 as many times as there are half-lives. But that doesn't work when there are an insanely large number of half-lives. I mean, certainly you could divide by 2. Say you had 150 half-lives. You could divide by 2 150 times, but that wastes time. You probably aren't going to have enough time on a quiz or a test to be sitting there doing that. And it's going to be really easy to lose track of how many times you've divided by 2. So there's actually an easier way. And this easier way is a formula. This formula is MO, which stands for original mass, times 1/2. That 1/2 is raised to the power of n, and that equals MF, which is final mass. So MO is original mass, MF is final mass, and N is the number of half-lives. Now, this isn't always true, but for my class, I will always make the number of half-lives be a whole number. It's not always like that, though. In other classes, it might not be a whole number, but for regular chemistry, your introductory chemistry course, I will make it a whole number to make your lives a little easier. Now, sometimes in a problem, you're told how many half-lives a substance has gone through. But other times, you're given time information. You're given the time that has passed, and you're given the length of the half-life. Now, we're going to say that time passed is just t, and length of half-life is t 1/2. Well, in order to figure out the number of half-lives, you take t and you divide it by t 1/2, and that will tell you n. All right, so if you don't get a whole number here, then you've done something wrong. Most likely you mixed up t 1/2 and t. So let's look at this problem. Fluorine 21 has a half-life of 5.0 seconds. If you start with 25 grams of fluorine 21, what mass remains after 60.0 seconds? Well, MO, my initial mass, my original mass, is 25 grams. I'm not told that X number of half-lives have occurred. I'm given time information. So I need to calculate the number of half-lives. Well, the half-life, the length of the half-life is 5 seconds, but the time that has passed is 60 seconds. So I'm going to take 60 seconds and divide it by 5 seconds. So that's 12. This substance, fluorine 21, has gone through 12 half-lives. So now we could take 25 grams and divide it by 2 12 times, but let's practice with the formula. So you're going to take 25 grams and then 1/2. The 1/2 you're going to raise to the 12th power, and that will get you the final mass. I suggest doing the 1/2 first, with the 1/2 to the 12th power first, and then multiplying that by 25. That way you don't accidentally raise the 25 to the 12th power accidentally. So when you do this, your final mass ends up being, now with proper sig figs, 25 grams is 2 sig figs, so we're going to need 2 sig figs, 0.0061 grams. And that's your final answer. Now, if you can't remember the formula, if all else fails, just divide by 2 the number of times that you have half-lives. Right? But the formula is good for when you have a large number of half-lives, and so you don't accidentally mix up how many times you've divided by 2.